Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 8.4, which is going to deal with the midsegments of triangles. So for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use the midsegment theorem to find angle and segment lengths. So for today, we're going to talk about what a midsegment is, and then how to use the midsegment theorem to find angle and segment measures. Now, before we jump into what a midsegment is and its properties, I just want to let you know that section 8.4 is the final section of Unit 2. So we have finally made it to the end of this long and lengthy unit, and just something I want to make you aware of. All right, so let's talk about what a midsegment is. The midsegment of a triangle is a line segment that connects the midpoints of two sides of a triangle, and every triangle has three midsegments. So what I'm going to do is kind of briefly use example 1 to touch on this idea before we really move forward. Now, example 1 wants us to go through and show that the midsegment of a triangle is parallel to the third side and half as long as the third side. Now, there's a whole long drawn out way to go through and do this whole problem. Before we jump into that, I just want to talk more about what a midsegment is. So a midsegment is going to be the middle point of, well, the midsegment is going to be a line segment that connects the midpoints of two sides of the triangle. So let's say that I find the midpoint of LM to be right here. And let's say I find the midpoint of MN to be right there. So let's say that those are my midpoints of those two sides. The midsegment is going to be the line segment that connects those 2 points. So this red line is called the midsegment of this triangle. Now, every triangle has 3 midsegments because I could find the midpoint of this line to be here and draw a line there and draw a line there. So that is what a midsegment is. Now that we have defined that, we're going to go through and talk about the properties. Now, example 1 would have us go through and actually kind of pre-talk about the different properties of midsegments, and we'll talk a little bit more about this, but it is the fact that the midsegment of a triangle is parallel to the third side and half as long as the third side. So what example 1 has us go through and do is show that PQ is parallel to LN. So they want us to prove that this red line is parallel to LN and that PQ is equal to half the length of LN, meaning this red line should be equal to half the distance of this line. So if this was 8, that means that this should be 4. If this was 3, then this should be 6. So example 1a is actually a pretty extensive example to run through. And instead of actually going through step by step on this example, I'm just going to pull up my completed notes. You can take a further look at example 1 in my completed notes on your own time. What I just want to briefly mention is I used the midpoint formula, the x1 plus x2 over 2, comma y1 plus y2 over 2 to figure out my midpoints at 6, 8, and 9, 5 to show the red line. To figure out if the lines are parallel, we'd have to go through and find the slope. So I went down 3 to the right 3 to get from P to Q, and then down 6 to the right 6 to get to from L to N. So the slope of the red line is negative 3 over 3, or negative 1. The slope of LN was negative 6 over 6, which is negative 1. And when we talked about the slopes of parallel lines back in section 4.5, the slope of parallel lines have to be the same. If they are the same, then the two lines are parallel. Hence, me saying that PQ is parallel to LN. So that is the first property, that those two lines are parallel, and that's going to help us to use corresponding angles, alternate interior, or same side interior angles. Now, the second part was to go through and prove that PQ, this red segment here, is equal to the half the distance of LN. So I went through and used the distance formula, that square root of x2 minus x1 squared plus y2 minus y1 squared. Go through and solve it. PQ is square root of 18, LN is the square root of 72, which equates to 4.24 and 8.48. So the question is PQ equal to half the distance of this, of LN? If I were to take 4.24 and multiply it by 2, I would get 8.48. And if I were to divide this by 2, I would get 4.24. So that is the brief, quick overview of example 1 that shows that PQ is parallel to LN and that PQ is equal to half the length of LN. So instead of kind of running through that step by step and taking 15 minutes to do it, I just want to briefly run through it and talk about it as I did, just to kind of show you how it works and that it does work. So with that said, we are going to use that property, which is going to be referred to as the triangle midsegment theorem, to help us go through and answer some questions today. So, triangle midsegment theorem is where we're going to go to next before we jump into example 2. So the triangle midsegment theorem states that the segment joining the midpoints of two sides of a triangle is parallel to the third side, meaning FE is parallel to RP. So these two lines are parallel to each other. And its length is half the length of that side. So it means this side right here is equal to half the length of this side. So using that, for example 2, they state that use the triangle midsegment theorem to find the following lengths or angle measures. So the first two problems in example 2 are going to have us dealing with side lengths. Now for A, it wants us to find the length of RP, which is this segment right here. Now, according to the midsegment theorem, I know that RP is parallel to FE, and that FE is equal to half the distance of RP. So that's going to be my equation, is that FE is equal to 1/2 the length of RP. So knowing that, okay, we're going to plug in the stuff we know. Well, I know that FE is 7 based off the diagram, so I'm going to plug 7 in for FE. So I now have 7 equals 1/2 RP. Now I need to find the length of RP. So to get rid of this fraction of 1/2, I'm going to multiply both sides by 2. If I multiply both sides by 2, that's going to cancel out the 1/2 and the 2 over here. And then I just have 2 times 7 over here, which is 14. And I'm left with RP on the right side. So that means I know that 14 is the length of RP, and that RP equals 14. And that is how we're going to use the triangle midsegment theorem to find a segment length. Alright, so if we look at B, for part B, they want me to find the length of FG, and using the triangle midsegment theorem, I know that FG is parallel to WY. So I know that those two lines are parallel and that FG is equal to 1/2 the length of WY. So FG is equal to 1/2 the length of WY. So we're going to plug in what I know, and what I know is that WY is 16. So we're going to have FG equals 1/2 of 16. And then there's no need really for multiplying in this case. I just have to go through and simplify this 1/2 times 16, or 16 divided by 2. And 1/2 of 16 is going to give me FG to equal 8. And that is going to be the length of FG. And thus my answer for part B. Alright, so those are some very standard basic examples to kind of run through and utilize the triangle midsegment theorem. Just know that this is equal to 1/2 of this. So if I'm going from the smaller segment to the larger, all I'm doing is multiplying this by 2 to get to this. And if I'm going larger to smaller, I'm just dividing by 2. So just something to keep in mind, if we're going smaller to larger, we multiply by 2. Larger to smaller, we divide by 2 to find the lengths. Alright, so with that said, we're going to move on to the back side, which continues example 2. And we have a host of different examples that we need to run through on the back side. Alright, if we look at our first example on the back side, so we have the triangle SRT, and they want us to go through and find the different measurements, whether it is side lengths, angle measures, or segment lengths. So we have the triangle SRT, and we have two mid-segments that are drawn in our triangle, and we're going to use both of them to figure out these measurements. So first, for part A, they want us to find the length of UW. So UW is going to be this length right here. And based off my diagram, I know that UW is the mid-segment related to ST. So this whole segment here. So I know that UW is parallel to ST, so these are my two related sides. I want to find UW, and they tell me that ST is 10.2. So to figure out UW, we're going to take 1/2 of 10.2. So we're going bigger to smaller, so we're going to divide by 2. So if we take 10.2 divide by 2, we end up with 5.1 as the length of UW. And that is my answer for part A. Now, for part B, we're going to get into our first angle measure. But for part B, they want me to find the measure of SVU. So SVU is going to be this angle measure here. Now, using our diagram, what is the only angle measure that they tell me in this drawing? It is the 41 degrees of angle VUW. So if we look at these two, and it would be helpful to rotate the figure. So if I were to rotate this triangle real quick, the pattern's going to carry over for a lot of them. But if I rotate this, if we think about it as two parallel lines cut by a transversal, Both of these angles are in between the parallel lines, and they're on alternate sides of the transversal, which tells me they're alternate interior angles. And if I know they're alternate interior angles, I know that they are the same measure. So, if I know that these two angles are the same measure because they're alternate interior, if I know this is 41 degrees, that means I know this one is also 41 degrees. And that is my answer for part B. All right, next for part C, they want me to find the length of RT. So RT is going to be this whole side right here. And RT is going to be parallel to UV, so this length right here. Now I want to figure out the length of RT, and they tell me that UV is 5.6. Like I talked about on the front side with example 2, part A, if I'm going from smaller to bigger, I'm going to multiply this smaller number by 2 to figure out my larger segment. So we're going to take 5.6 and multiply it by 2 to figure out the length of RT. If I do 5.6 times 2, we get 11.2. So the length of RT is 11.2. Again, if we're going smaller to bigger, we multiply by 2. If we're going bigger to smaller, we divide by 2. So that's how you're going to find the length of segments today, is either multiplying by 2 or dividing by 2. Multiply is when you go smaller to bigger. Dividing is when you go larger to smaller. All right, so that is parts A through C. Next, we're going to take a look at our second diagram to figure out parts D through F. So if we look at D through F, we are given another diagram, and we're given the triangle JKL, and again we have two mid-segments drawn for us. So the first thing they want me to find is the length of JL for part D. So JL is going to be this segment right here, and the side or the mid-segment that is parallel to JL is going to be PN. So that's going to be this segment right here. So PN is parallel to JL. That means this is where my relation is going to be at. If I want to figure out JL, we need to use the length of PN, which is 39. So if PN is 39, to go from smaller to bigger, we have to take 39 times 2. Because we're going from the mid-segment to the third side, smaller to bigger, we need to multiply. So we're going to do 39 times 2. And if we do 39 times 2, we end up with 78 as the length of JL. Alright, next, for part E, they want me to find the measure of MLK, the angle of MLK, which is this angle right here, right there, excuse me. So MLK is this angle, and the only other angle measure that they tell me in this drawing is JMP, which is going to be 105 degrees. So MLK and JMP are the two angles that we're going to utilize to figure out the measure of MLK. What type of angle relationship does these two angles appear to be? Are they corresponding, alternate interior, or same side interior? So they are corresponding, and corresponding angles tell me that they are congruent, So that means I know the measure of angle MLK is 105 degrees. Excuse me. So I have figured out the measure of angle MLK by knowing that I have two parallel lines cut by a transversal and that these two angles are corresponding, which means they are congruent. Alright, for F, they want me to go through and find the length of PM. PM is going to be this midsegment right there, and this midsegment of PM is parallel to this segment of LK. So, if I want to figure out the length of PM, and I know that LK is 95, to go from bigger to smaller, we're going to take this segment and divide it by 2. So we're going to take half of 95 to figure out the length of PM. So we're going to take 1/2 of 95, and half of 95 is going to be 47.5 for my length of PM. Again, bigger to smaller, we take half or we divide by 2. Smaller to bigger, we multiply by 2. Alright, so with that said, that's just kind of going through and figuring out based off just generic numbers in our diagrams. Next, we want to step it up to the fact of having expressions instead of necessarily just angle measures or side lengths. So, with that said, let's go ahead and take a look at G and H for our next problems. Alright, for G and H, we're going to continue using the midsegment theorem, where the midsegment is parallel to the third side, and the midsegment is equal to half the distance of the third side. So for G and H, we need to go through and find the value of x. So if you notice for both of these problems, I have expressions for the midsegment and the third side, and we need to go through and figure out what x equals. So with that said, I know that UV is parallel to GE, so that means I know UV is equal to 1/2 the distance of GE. So we can go through and plug in the expressions into that formula of UV equals 1/2 of GE. But before we do that, I find a way to deal with expressions in x, because sometimes we have odd numbers and we get decimals, is to also think about it as 2 times UV equals GE. Okay, I find multiplying by 2 is better than dividing by 2 when we're dealing with expressions, and it just keeps it a little more clean. So, I know that UV is 2x minus 4, so we're going to do 2 times 2x minus 4 equals GE, which is 3x minus 2. Alright, so first thing that I need to do is to multiply the 2 into this 2x minus 4. So we're going to distribute the 2. So 2 times 2x is 4x, and 2 times 4 is going to give me a minus 8. So I have 4x minus 8 equals 3x minus 2. If I would have divided this by 2 instead of multiplying this by 2, I would have had a 1.5x minus 1, so we would have been dealing with decimals. Alright, so next we have to get x on the same side and the numbers on the other. So if I have 4x minus 8 equals 3x minus 2, I can either move the 4x to the right or move the 3x to the left. I'm going to move the 3x to the left. So if I do 4x minus 3x, 4 minus 3 is 1. So this becomes x minus 8 equals negative 2. Then all I have to do is just add 8. So if I do negative 2 plus 8, I end up getting x to equal 6. And that is my answer for what x equals for part G. All right, for H, we're just going to run through the same idea. So I know ST is parallel to HF. And if I know that, then I know that ST is equal to 1/2 the length of HF. Or the other way I can think of it is 2 times the length of ST is equal to HF. So I'm going to use the second one of 2 times ST equals HF to go through and plug my stuff in. So I know that ST is 2x minus 18. So we're going to do 2 times 2x minus 18 equals HF, which is 2x minus 12. So from here, what we need to do is multiply that 2 into the parentheses, or distribute it. So we're going to do 2 times 2x and 2 times 18. So I get a 4x minus 36 equals 2x minus 12. All right, from here we just need to go through and solve per normal. So I'm going to move the 2x to the left. So 4x minus 2x is 2x minus 36 equals negative 12. I add the 36, so negative 12 plus 36 is 24. So I have 2x equals 24. And if I were to divide 24 by 2, I would get x to equal 12. So in this case, related to the midsegment, for H, I know that x equals 12. All right, so that is how we go through and use the midsegment to find angle measures and lengths of the midsegments or a side length using the midsegment theorem. Now, before we end for today, as that's going to be a majority of your work today, I do want to quickly talk about example 3. And example 3 is going to pull the idea of the midsegment theorem to help us go through and talk about a few ideas relating with it, if we were to apply it. So for example 3, okay, this part right here wants us to compare the perimeters of triangle ABC, so the whole larger triangle, and triangle DEF, which is considered the midsegment triangle. So ABC is our larger triangle at whole, and triangle DEF, like I said, is considered our midsegment triangle. So it wants us to go through and compare the perimeters. So I'm going to use hypothetical numbers for this whole problem. So let's just say, hypothetically, that the length of AC is 8, the length of AB is 6, and the length of BC is 10. Now, there's no exact reason why I necessarily use those numbers. I'm just using them because they give us nice numbers to really consider. So, if I were to say that these are the length of all these sides, the perimeter of triangle ABC, the perimeter is adding up all 3 sides. So 8 plus 6 plus 10, and that gives me 24. So the perimeter of triangle ABC is 24. Next, we need to consider the perimeter of the smaller triangle of DEF. Remember, midsegments are equal to half the distance of the side it's parallel to. So if I want to know DE, it's half the distance of 8, so that would make this 4. FE is parallel to AB, so this is equal to half of this. So if this is 6, that means this is 3. And then FD is parallel to CB, so this is equal to half of this. If this is 10, that means FD is 5. So my smaller triangle is 3, 5, and 4. If I want to figure out the perimeter of the triangle DEF, if I do 5 plus 4 plus 3, we end up with 12 as my perimeter of that triangle. So using these just basic standard numbers, what is the relationship that we notice? How can we compare these two perimeters? Well, the perimeter of ABC is double the perimeter of DEF, or DEF is half the size of ABC. And that is going to be our comparison and our look at comparing the perimeters of ABC and DEF. So know that the smaller triangle is half the size of the larger triangle, and the larger triangle is double the size of the smaller triangle. Alright, and then lastly, for this part, it asks why is XY not a midsegment of the triangle? So why is this segment not the midsegment of this triangle? Okay, XY is parallel to this third side here, so that is good, but XY is not at the middle or the midpoint of both these sides, as this is 6 and this is 5, and this is 6 and this is 5. So X and Y are not the midpoints. And that is why it's not the midsegment. So it has to be in the middle between those two segments for it to be the midsegment. All right, so with that said, that is all for our lesson today on section 8.4, dealing with the midsegments of triangles and using the midsegment theorem that the midsegment is parallel to the third side and it's equal to half the length of that third side. So with that said, that is all for today. I appreciate you guys taking the time to listen. If you have any questions, as always, just let me know the next time you see me or shoot me an email. Be sure to use the completed notes as you work through the homework. And that is all for today. So thank you guys for listening, and I hope you have a great day, and I'll talk to you guys later. All right, bye.